This is Group 5 Practical and Video for Fundamentals of Computer Hardware and Software. In this presentation, we'll be going over how to install software and describe how it is used to manage the security of a computer system, describe the structure and different software and operating systems, describe the system unit components, registry, CMOS, and BIOS, explain the role of the central processing unit, monitor, and keyboard and mouse in functions of computer system. Objective 1. Install utility software and describe how it is used to manage the security of a computer system. Now we're going to show you how to install AVG antivirus on your Windows desktop. What is an antivirus? Antivirus software is a program that detects, prevents, and removes malware infections from computers, networks, and IT systems. They usually run in the background, scanning computers, server, and mobile devices for malware and preventing it from spreading. Examples of antivirus are Bitdefender and AVG antivirus. Objective 2. Describe the structure of different software and operating systems. Structure of Linux. Linux architecture has two layers, user space and kernel space. Hardware, kernel, system call interface or shell, and user applications or utilities are the four main components within these layers. All peripheral devices connected to the computer, such as monitors, printers, CPU, and RAM, are considered hardware. The monolithic kernel, which is the OS core, is next. There are numerous subsystems and other components in the Linux kernel. Process control, networking, accessing peripherals, and the file system, security management, and memory management are just a few of the critical tasks it handles. The shell serves as an interface between the user and the kernel, presenting the kernel services. Shell takes the user's command and runs them through the kernel. Command line shells and graphical shells are the two types of shells. We have applications that execute on the shell in the architecture's outermost layer. Any utility program can be used, such as a web browser or a video player. Structure of Windows. The architecture of Windows is divided into two layers, kernel mode and user mode. User mode. There are integral subsystem and environmental subsystem in user mode. Fixed system support processes, service processes, security subsystem, and user applications are all integral subsystems. The environmental subsystem serves as a connection between user mode applications and OS kernel functions. Kernel mode. Kernel mode has full access to the computer's hardware and resources. It runs the code in a secure memory space. Executive, microkernel, kernel mode drivers, and hardware abstraction layer (HAL) are all part of it. The executive services in Windows are further divided into subsystems. Memory management, I/O management, thread management, networking, security, and process management are among their primary responsibilities. Between Windows Executive and HAL is the microkernel. It is in charge of multiprocessor synchronization, thread scheduling, interrupt and exception dispatching, trap handling, device driver initialization, and communication with the process manager. Windows can interact with hardware devices using kernel mode device drivers. HAL is a software layer that sits between the operating system and the computer hardware. It is in charge of I/O interfaces, interrupt controllers, and a variety of processors. Application software. Software that executes specific tasks for a user is called application software. Examples of application software are Microsoft Excel and Firefox. Utility software. Utility software aids in the management, maintenance, and control of a computer and the support of its infrastructure. Utility software is a collection of tools for configuring, analyzing, and optimizing computer resources. They provide added functions to a computer such as file management, data recovery, disk defragmentation, and computer resources. Examples of utility software are disk cleanup and AVG antivirus. Objective 3. Describe the system unit components, registry, CMOS, and BIOS. System unit components, motherboard. The motherboard is a printed circuit board that connects all components in a system unit. The motherboard is essential as it allows for each component to communicate with each other and provide power to some connected components. CPU, or Central Processing Unit, is the component that controls the computer's speed. This is mounted directly onto the motherboard and processes all instructions from the computer, whether it is hardware or software. Memory. The primary storage or memory stores temporary data currently being worked on by the Central Processing Unit. This needs electricity to keep the data stored, as once it is powered off, the data is erased. Storage. The computer stores its permanent memory on a secondary storage devices, such as hard disk drive or solid-state drives. These devices hold data even when the power is turned off. Power supply. The power supply is a hardware component in a system unit that provides power to all the components at the correct voltage. Input unit. Input unit are devices that send instructions to a computer to process. Some examples of input devices are keyboard, mouse, microphone. Output unit. After data is processed, it returns a result. Output devices are used to see the results in human-readable format. Some output devices are monitors, speakers, and printers. Registry. The Windows Registry is a database used by Microsoft. This database consists of settings for Windows. It contains configuration for hardware devices, applications that are installed, and the Windows operating system. CMOS. Complementary metal oxide semiconductor, or CMOS, is a component on the motherboard that stores information. The CMOS is battery powered and crucial to the system operation as it stores the system time and date as well as system hardware settings. BIOS. BIOS, or Basic Input-Output System, is a read-only memory chip on the motherboard that allows users to access and set up the computer system. This system includes instructions on how to load basic computer hardware. This system is where the computer will do a self-test called POST, or Power On Self-Test, which checks to see if the computer can successfully turn on or has failed the requirements to boot successfully. Failure in this test results in a series of beeping sounds from your computer that indicates the problem. Objective 4. Explain the role of Central Processing Unit, monitor, keyboard, and mouse in functions of the computer system. Central Processing Unit. The Central Processing Unit directs the computer through each step of the problem-solving process. Data is fed into the computer via an input unit processed by the Central Processing Unit and then made available to the user via an output unit. A logical perspective of a computer depicts the machine's functions. A physical view of a computer demonstrates how the computer's mechanisms conduct various activities. The arithmetic and logic unit, primary storage, and control unit are the three logical units that make up the Central Processing Unit. Active applications and data are stored in the main storage. Computer monitor. A computer monitor is a display adapter that displays data processed by the video card in the computer. Images are displayed on the immediately attached monitor when a video card or graphics card translates binary information from ones and zeros into images. Monitors come in a variety of shapes and sizes, including cathode ray tubes and liquid crystal displays. Powering on and off a monitor, as well as changing brightness, contrast, and location are all display functions. Computer keyboard. A computer keyboard is an input device that uses buttons and keys to insert characters and functions into a computer system. It is the most common method of text entry. Individual letters, numbers, and special characters, as well as for special operations, are often found on a keyboard. Computer mouse. A computer mouse allows the user to move a cursor around a two-dimensional plane in a fluid and intuitive manner. As a result, it is a must for picking, dragging, hovering, and clicking. Users can switch between apps, choose choices and buttons, and move around the screen with amazing accuracy and agility using the mouse. It's used to navigate and select links on websites, button on an option screen, menu entries, and a variety of other things that would be significantly more difficult to accomplish with just a keyboard. Thank you, and that concludes our presentation. Next, you will see a list of our resources used for this.